I have some code here that declares two strings and compares them for equality. As usual, I have a sanity check that they are separate instances using reference equals. Then I check for equality using both the operator and the method. I also check for equality using the static equals method, just so you can compare with the other techniques. We should know by now what this will do. Reference equals will return false because they are different instances. All the other methods will return true. I'll just run that. That's what we expect. Now I'm going to make one change and change the variable declarations to be of type object. I'm still initializing them as strings, but I'm losing the type information, so I'll need to cast back to string to make the call to copy compile. This change is not good coding practice, but it surely shouldn't change anything in the results. Let's check. It has changed the results. All the methods have still worked correctly, but the equality operator now claims the strings are not equal, and worryingly, the operator gives different results from the methods. And the reason for that is that the equality operator is not virtual. Remember, it's equivalent to a static method, and static methods are never virtual. In this equals equals line, we are asking to compare two variables that are both of type object. We know that they actually refer to strings, but the compiler doesn't know that. For non-virtual methods or operators, the decision on what method to invoke has to be made at compile time. And since these variables are of type object, the compiler will emit code that compares objects for equality. And because there's no equality operator overload for objects, the result will be what equals equals always does for reference types when there's no overload available. It will do reference equality. And since these strings are different instances, reference equality will evaluate as false. This problem doesn't affect either of the equals methods because the virtual equals method is, well, virtual, so the correct override, in this case strings override, will always be called at runtime, and the static equals method also works correctly because, as we've seen, internally it works by calling the virtual method. And that's one reason why you might want to call an equals method rather than using the operator. The methods are likely to play better with inheritance. Incidentally, a side effect of this is that casting to object and calling the equality operator will always give the same result as calling reference equals. And I've seen code where people have done that in order to do reference equality. I'd be a bit careful of doing reference equality comparisons that way myself though, because a lot of developers won't understand that the cast forces the equality operator to do reference equality. But a call to reference equals leaves no room for doubt what you want the code to do.